Hello students, here I have come with a new video where I'll be solving prelim paper of the year 2025 and we'll do the detailed illustration of this paper. It will take time. You have to stay on till the end of the video. Understand how the questions are asked and what is expected from you to write in a paper, how much to write and what to write. I'll give you the whole idea about this. So the paper starts with MCQ over here. So question asked is the linkage connecting monosaccharide units in polysaccharide is called. So the answer is this answer given over here is very theoretical. The answer is glycosidic linkage. Now what is the meaning of glycosidic linkage? Let's consider this polysaccharide of the starch. Okay, starch has two components. One is amylose and the amylopectin. I have considered the amylose. So over here, this linkage which is connecting two monosaccharide units are called as a glycosidic linkage. In this case, it is called as 1,4 linkage. So this is the name. This is called as glycosidic linkage. We'll go with the next question. With respect to this question, not only with the polysaccharide, with the disaccharide or with the trisaccharide, the linkage which connects the two monosaccharide unit is always called as a glycosidic linkage. Okay, next question. The catalytic activity of the transition metal and the compound is mainly due to their dash. The answer is straight again, ability to adapt the variable oxidation state. What is the meaning of the variable oxidation state? Transition metals have variable oxidation state. They don't have fixed oxidation state. Like if you consider the group 1 elements like a sodium or a potassium, rubidium, cesium, francium, they will mainly have the oxidation state of the +1. If you consider group 2 element, beryllium, magnesium, calcium, strontium, barium, radium, they will have fixed oxidation state of the +2. But if you consider the compounds like the transition elements of the I'll consider Fe is the compound of the transition metal, transition element. It will exist in a variable oxidation state. One compound is FeO, other is Fe2O3. Okay, like in this case, the oxidation state of the Fe is +2. Over here it is +3. Okay, if we consider another compound like manganese, MnO2 is also existing and other compound is KMnO4. The oxidation state, if you check, over here it is +4, here it is +7. Okay, that is not the case with these elements. So this is what is the meaning of the variable oxidation state. So answer is the ability to adopt the variable oxidation state. Next question, orthonitrophenol is less soluble in water than its para and meta isomer. Okay. Now, first we'll understand the solubility is because of what. Okay. See, solubility is because of the presence of some similar intermolecular forces. If we consider what is said, it is not that it is not soluble. Over here, what is the question is orthonitrophenol is less soluble in water than para-meta isomer. Okay, we'll understand this with the help of this. First, we'll understand what is hydrogen bond. Okay, so in the options they have given hydrogen bond. So hydrogen bond, what is the meaning of hydrogen bond? It is intermolecular force. First of all, it is intermolecular force. It is intermolecular force, a strongest one compared to any other. It is the strongest intermolecular force which holds molecules together. Okay, now what is the condition for the hydrogen bonding? What is the condition for the hydrogen bonding? Condition for the hydrogen bonding is that there should be should be presence of hydrogen and electronegative element in a compound. Electronegative element in a compound, provided hydrogen is connected to what? Hydrogen is connected to electronegative element. Like for example, I'll give you one example over here. In the case of water, there is hydrogen and the electronegative element, and hydrogen is also connected to oxygen. And in the case of acetone, if we consider over here, there is hydrogen and the electronegative element, but hydrogen is not connected to electronegative element. So here no hydrogen bond. Okay, means hydrogen bond, how it works is this way. This is one water molecule, this is another water molecule. The bond which holds them is this force which holds, like this is the hydrogen bond. Over here no hydrogen bond. So this is the condition. Here there will be a dipole force which holds the other molecule. Now something to get dissolved in water, it should form the hydrogen bond with water molecule. Now I'll write the structures of the orthonitrophenol, paranitrophenol, metanitrophenol. So we'll write the structures of the phenols. So this is OH, and I'm writing orthonitrophenol, O and the positive. Over here there is intramolecular hydrogen bonding. In meta, this is NO2. In this case, what happens is that since this group are little far from one another, the intramolecular hydrogen bonding is not possible. And in this case also, in para nitrophenol, groups are still apart from one another, therefore the intramolecular hydrogen bonding is not possible. Now as a result of this, both these compounds forms strong intermolecular hydrogen bonding with water. And with this, already it is forming internally with molecule, like I'm talking about the orthoisomer. This is meta and this is para. So already it is forming. So the force of attraction between this molecule and water is little less. Over here the maximum force is there. So therefore orthonitrophenol is less soluble. So this is because orthonitrophenol, question answer will be orthonitrophenol shows intramolecular hydrogen bonding. That's the answer. Okay, here's the next question. Question asked is the solubility of gas in liquid increases in like water, increase in temperature or decrease in temperature, amount of the liquid taken, reduction of the gas pressure. So answer to this is very same. What happens is that if we talk about the temperature, so temperature, what temperature tend to do? Temperature increases kinetic energy of gas molecules. If kinetic energy of the gas molecules is high, then what will happen? If this is your liquid, let's say this is the liquid, this is your liquid, and you want to put some gas particles inside this, and it will not get dissolved if the kinetic energy of these particles is more, if it is constantly moving. So what happens is that if you want to increase the solubility of gas in liquid, then temperature should be lower. So the answer over here is a decrease in temperature. Next question, the correct order for following compounds in increasing order of the boiling point. So over here, if you see these compounds, the molar masses are same for all these compounds because they are isomers. They are isomer, like the molecular formula of this is what, C4 H9 Br. Here also C4 H9 Br, and this is also C4 H9 Br. So for a boiling point, understand, boiling point of isomers, isomeric alcohols, in this case it is alcohols, decreases with branching. More is the branching, less is the boiling point. If you see, 3 is the one which has the maximum number or maximum branching, then 1, and then 2. So among these, 2 will be the one which will have the maximum boiling point and 3 will be minimum. So which option matches correctly over here is option this. Okay, 3 will have least, then 1, and maximum will be for the 2 because it is the unbranched molecule. Acid form when N-propyl magnesium bromide reacts with dry ice in the presence of the dry ether followed by acid hydrolysis. Now first of all we have to understand what is the meaning of this dry ice. Dry ice is very simple. Dry ice is equal to what? Carbon dioxide. See, we have to do the reaction of the carbon dioxide with Grignard reagent. That is, this is N-propyl magnesium bromide is actually a Grignard reagent, means CH3, CH2, CH2, magnesium bromide reacts in the presence of dry ether, this is a solvent which is taken over here. The compound, like we have to understand at this point, is that these bonds remains intact. Like when we do the reactions of the carbonyl with a Grignard reagent, it is similar kind of reaction. In that case, this bond remains intact, these two bonds remain intact. Now this two bond will remain intact. So over here what will happen is that this bond, one of the double bond I am keeping intact, other changes to what? OMG, and this is the R group. This R group will connect to this, and this R group is what? CH2, CH2, CH3. Means further if we do the hydrolysis, of this, what will happen? What do you get is this C double bond O, this is OH, this is CH2, CH2, CH3. It is same as writing this CH3, CH2, CH2, CO, OH. So what is this? This is butanoic acid. This compound is butanoic acid, right? So the answer is this butanoic acid. Okay, here is the question. Question asked is for the reaction. This is the reaction given, and the rate law has been found to be this is the rate law they have given, although the rate, also the rate constant is given, and also the rate of reaction is given. So how do we solve this? Very simple approach. Rate is equal to k n2O5 square, right? Rate is given to be is equal to 2.4 into 10 raised to minus 5. K is given to be is equal to, rate constant is 3.0 into 10 raised to minus 5 rate constant, and concentration of N2O5 the whole square. So if you see this, 2.40 divided by 3.0 is equal to N2O5 the whole square. Okay, and this answer, if you solve, this will come to 0.8. How 0.8? You can convert this to 24 and 30. N2O5 the whole square. Okay, so 24, 6 4 is 6, 5 is 4 by 5 is 0.8, and N2O5 the whole square. Now the thing is, square, no, this is, I am getting the answer as N2O5 the whole square is equal to 0.8. So what is the concentration of N2O5? It is square root of 0.8. And what is the square root of 0.8? If we calculate the square root of 0.8, then the value would come to value comes to 0.89. This is the square root of 0.8. But in the option, the answer, closest answer matching with this is 0.8 only, right? The other answer are far apart, so answer is 0.8. Next question. In the Daniell cell, when an external opposite cell potential greater than 1.1 volt is applied, okay, electron flows from zinc to copper or electron flows from copper to zinc. See, you have to understand Daniell cell. How the Daniell cell diagram is there? Like, there is, I'll just draw it roughly. There is this half cell, this is another half cell, okay. There are electrodes like this. Let's say this is the electrode, this is another electrode, other side, okay. This is zinc, this is copper. There is one salt bridge over here, there is one salt bridge, and these are the electrolytes, over here the electrolyte present is zinc sulfate, here it is copper sulfate. This is connected, there is a wire, and basically in this case zinc undergoes oxidation because zinc is an anode over here, because it has less reduction potential than the copper. Cathode has higher reduction potential, so zinc undergoes oxidation, Zn undergoes Zn2 plus, and it loses 2 electrons. So over here electron travels in this direction, zinc to copper. This is a normal electrochemical cell where the reaction takes place in a direction, and the electricity, a small amount of the electricity is generated. What they are saying is that, and the potential difference, okay, voltage of this cell, the voltage of this Daniell cell is given in NCERT to be 1.1 volt, okay. But if we apply the external potential, I'll show you with a different, like this is, let's say, external potential which I am applying over here, whose value itself is more than 1.1 volt. So what will happen? The reaction will reverse and the electron will flow from copper to zinc. So electron flows from copper to zinc electrode. That's it. Here is the question. Question asked is Jovita notices that her gums bleed while brushing and eating food. Name the water soluble vitamin that she should consume to prevent bleeding of the gum. There is no explanation for this, but direct question asked from the NCERT biomolecules. That is water soluble vitamin. They have asked. Water soluble vitamin is vitamin C. Okay, answer is vitamin C for this. That's it. Next is simply the question is made complicated. There is nothing big in this question. Neha was given two test tubes. Test tube label as A and B containing ethylamine. Basically, it is ethylamine. Ethylamine structure will be CH3, CH2, NH2, and third is test tube B contains trimethylamine. Trimethylamine. Okay, trimethylamine will be what? We have nitrogen, CH3, CH3, and CH3. Means two samples are there. This is primary amine, this is primary amine, and this is tertiary amine. She adds reagent X, certain reagent X, okay, to both the test tubes, and observe that ethylamine reacts with reagent X and forms the product which is soluble in alkali, whereas trimethyl does not react with the reagent X and identify the reagent X. I will tell you the simple sequence for this reaction. It is this simple. How you have to remember? First of all, the answer I will tell you. Answer is the X is a Hinsberg reagent. Hinsberg's reagent. Okay. Also known as benzene sulfonyl chloride. Structure is this: benzene sulfonyl chloride. Now, what is the use of this? This is used for the detection of primary, secondary, and tertiary amine. This one reagent, the speciality of this one reagent, that it can tell whether the given amine is primary, secondary, or the tertiary amine. Now, what is primary, secondary, tertiary amine? If you don't know that, just Google it, you'll understand. Okay. I'll tell you the thing, how it works. Working of this. Working is very simple. You have tertiary amine. Let's say you have tertiary amine, and we'll start with the primary amine. Okay, you have primary amine. Okay, I'll take one example of the primary amine. Okay, same primary amine will take, very crucial, ethyl amine, which is there, CH2 and NH2. This will react with a benzene sulfonyl chloride. Like you see that there is a lone pair, this is a partially positive. The attack will take place from here to here, and the product what you get over here is this C double bond O. This Cl bond will break, and new compound which will form is NH. One more hydrogen will also go from here, CH2, CH3. Now this compound which is there, it has one acidic hydrogen. You understand that this nitrogen has one acidic hydrogen. Why this is called acidic hydrogen? This is acidic hydrogen because if you remove this hydrogen, the negative charge which will be formed over here will be more stable one. Okay, that's why it is acidic hydrogen. If this has a acidic hydrogen, then obviously this compound is soluble in NaOH, means it will react. It is soluble, means I will say that this is soluble compound. You will get the precipitate over here. You will get the precipitate. Okay. If it is secondary, means basically thing is that NaOH will react. Reaction will take place over here. Reaction will take place. Very important. If it is secondary amine, I'll show you the secondary amine. You are given a tertiary amine. I'll take secondary amine, NH and CH3. This is primary amine. This is secondary amine. You are reacting a benzene sulfonyl chloride as C double bond O Cl. So over here again this will react with this chlorine, sulfur and chlorine will go, and the product what you get is this. N. Now this hydrogen won't be there. There is CH3, CH2 and CH3. Now if you react this NaOH over here, no reaction, insoluble. I will write insoluble in alkali, insoluble it will become. Why? There is no acidic hydrogen, The reason is that there is no acidic hydrogen, means further it won't react. That is the thing. And if you consider the tertiary amine, how do we write the tertiary amine? If you consider like what is given, I will consider this. This itself will not react with a benzene sulfonyl chloride. Okay, even if it reacts, the reaction will reverse. So I'll write no reaction. For this to happen, there should be a hydrogen over here. No reaction is taking place. Means in short, what we have to understand is that for a primary amine reacts with Hinsberg reagent. Okay, I'll write this way. Primary amine reacts with Hinsberg reagent and NaOH. Secondary amine reacts with only Hinsberg reagent. And tertiary amine do not react with any of this. Do not react with Hinsberg reagent as well as NaOH. So that is what the thing. So over here answer is just one. Answer is just given as a Hinsberg's reagent. I just explain you the mechanism because for exam the question could be in any form. So you have to know the concept well. Okay. Next is complete and balance the following reaction. This is simple reaction which is based on balancing of the redox reaction. I'll explain you this. First we'll write. Let's not worry about what is this H plus. First we'll understand. This H plus tells you about the acidic medium. Understand that whenever it is MnO4 minus, manganese, okay, when it reacts with oxalate C2O4 2 minus in acidic medium, this gets converted to Mn2 plus and C2O4 2 minus gets converted to carbon dioxide. This example is a pure example of balancing of the redox reaction. If you know to balance the redox reaction, you can easily answer this. Okay, So we'll understand how to balance this redox reaction. So first step 1 I'll write. Shortcut I'll show, I'll not show all the steps. This is step 1. Figure out what is the oxidation state of the MnO4. MnO4 has the oxidation state of +7. Carbon has the oxidation state of +3. And over here carbon has the oxidation state of +2. How did we calculate the oxidation state? We should know how to calculate the oxidation states first. Okay, I'll explain over here also. What is the oxidation state? How to calculate that of the MnO4? I am calculating oxidation state of the Mn in MnO4 minus. So this is that. So I'll put this Mn as X plus 4 into oxygen is -2 unless and until it is peroxide. So mostly it is -2 equals to -1. X minus 8 is equal to -1. X is equal to -1 plus 8. X is equal to +7. So this is the oxidation state of the Mn in MnO4 minus. Now what is the oxidation state of carbon in C2O4 minus? So I'll consider this as 2x. Over here I'll write 2x because 2 carbons are there. 4 into -2 equals to -2. So 2x minus 8 is equal to -2 and 2x minus 2x is equal to -2 plus 8. 2x is equal to 6. X is equal to +3. Means that's why it is +3. And in the carbon dioxide, it's very simple. You take x plus 2 into -2 equals to 0 because there is no any charge on this. X minus 4 is equal to 0. X is equal to +4. So these are the oxidation states. This is how we calculate the oxidation states of the given compound. So I'll take this down. So this was a short explanation how to find the oxidation state. Okay. Let us understand what is happening over here. If you look carefully, +7 is changing to from here. +7 is going from +7 to +2. So what is this? This is the reduction. This is reduction. Reduction means gain of electron. 1 Mn changes to Mn which was in a +7 oxidation state changes to +2. So reduction from +7 to +2, the difference is of 5 electrons. So gain of 5 electrons. Okay. Over here first what we'll do is we'll balance the in this case we'll balance the atoms of the carbon. Oxygen we don't have to balance, it will get balanced automatically at the end of the reaction. So over here there are 2 carbon. I'll make this 2 over here this way. Now from +3 to +4, this is what? This is oxidation. This is oxidation. Right? I'll write. This is oxidation. And there are actually 1 carbon is going from +3 to +4. So it is a loss of 1 electron. But there are 2 carbon which goes to +4. So total it will be loss of 2 electrons. Means 1 electron per carbon atom. So how do we do this? Now you see over here in both the cases the number of electrons are different. We need to make it equal, and it is very simple. I'll multiply this with 5 and I'll multiply this with 2. This with 2 means what? I'll write 2 over here and I'll write 2 over here. Okay, I'll do that in a second step. Step 2 I'll write 2 over here. 2 in front of the manganese MnO4 minus. In front of the carbons like oxalate I'll write 5 C2O4 2 minus. Okay, and here again it is 2 Mn 2 plus because we are multiplying 2 to this, and over here this 5 to the 10 carbon dioxide. Now if you check the charges over here, it is 2 into -1 plus 5 into minus 2. This side this is 2 into plus 2. This comes to minus 12 and this comes to plus 4. I need to make it equal. I need to make these charges equal. I need to make these charges equal by adding appropriate number of the H plus. Why appropriate number of the H plus? Because it is in the acidic medium. Okay, so step 3 I will write. Step 3 is 2MnO4 minus plus 5C2O4 2 minus. Already there is minus 12 charge, this side plus 2. So if I add something 16H plus, 16H plus means 16 positive and negative 12. So this comes to 4. If I add 16H plus, so I'll add 16H plus. Other side 2Mn2 plus and 10CO2, 16H plus, therefore 8H2O. So this is the balanced chemical equation which is expected from you to write in the boards. This is a simple explanation. Okay, this was expected in that question. Okay, how many H plus, Mn2 plus. Okay, fine. Question is state Faraday's law of electrolysis. Directly this question is asked. First law, I'll write the law over here. The law states that the amount of the chemical reaction, the amount of chemical reaction which occurs at any electrode during electrolysis by a current is proportional to the quantity of electricity passed through the electrolyte. This is a law. Through the electrolyte. That's it. Next question. Over here the major product is asked over here. It starts with this. Okay, half of the reaction is given. Acetone. CH3. This is acetone. Okay, name of this compound is acetone, also known as propanone. Understand, 3 carbons are there. Propanone. This is sodium borohydride. Sodium borohydride is a reducing agent. Okay. Now thing is very simple. How to solve this? If you know that sodium borohydride is a reducing agent, the thing is very simple. Many times students should be taking a help of this, that you should know that if it is a primary alcohol, and if you do the oxidation, of this by using certain oxidizing agent, it will get converted to the aldehyde. And if you do the oxidation of this, if you do the further oxidation of this, it will get converted to carboxylic acid. Okay, this is one simple flowchart you should be knowing. And if you do the reduction of the carboxylic acid, it will get converted to aldehyde, and aldehyde, if you do the reduction, it will get converted to primary alcohol. But if it is a secondary alcohol, and if you do the oxidation of this, then it will get converted to ketone, and if you do the reduction of the ketone, then it will get converted to secondary alcohol. That's it. Means over here we are doing the reduction of the ketone, means this will get converted to the secondary alcohol. What is that secondary alcohol? COO. This is secondary alcohol. Reduction. You add one hydrogen over here, you add another hydrogen on another carbon, right? So this is the name of this is isopropyl alcohol. Propyl alcohol, also known as propanetol. IUPAC name is propanetol. Now further the question is about, you are adding 85% H3PO4, which is the meaning at 440 Kelvin. What is the meaning of this? You are adding a acid to this. At this temperature. So whenever you add acid to the alcohol, another thing you have to figure out, whenever addition of acid to alcohol leads to dehydration or loss of water in most of the cases. Okay, so here you see that this is the elimination reaction going to take place. Like CH3, I'll write it this way, CH2 and H, you remove this water molecule. So what is the compound you are going to get? CH3 CH double bond CH2. The answer what you get is a propene. That's it. Next is calculate the EMF of a given cell at 298 Kelvin. Okay. EMF is asked. I'll write the whole Nernst equation. You will have to use a Nernst equation for this. Nernst equation. What is the Nernst equation? It says that, see, anytime you get a problem for a 2 marks, remember that half marks is for writing a formula, half marks is for correct substitution, half marks is for the correct answer, and half marks for the unit. Half marks for formula, half marks for substitution, half marks for answer, and half marks for what? Writing the unit. Okay. So I'll write the equation. Nernst equation is EMF of cell, E naught cell minus 0.059, like this is short form we are writing, upon N, log of concentration of the reactant in anode half cell upon the reactant in a cathode half cell. See, understand that for this you require a overall reaction. Overall reaction is very important. This is where many students make mistake. They don't understand how to write a overall reaction. Anytime whenever you have a Nernst equation, you should have the overall equation, and how to get that overall equation is from the half reactions. Unless and until you have the overall equation, you cannot solve this problem, right? So if you understand, if you look at this, we'll write the overall reaction first. It is advantage that we'll get to know what are the stoichiometric coefficients. Stoichiometric coefficients will help you write the over here. What is the concentrations, powers to which concentration terms are raised. So I'll write the reaction. There are two reactions which are taking place. One is anode half cell. Okay. I'll write oxidation half reaction. Oxidation half reaction. I'll write it very simple. Oxidation. What is getting oxidized? If you see that nickel is in the left side. In the cell representation, this is a cell representation over here. This is cell representation, and nickel is in the left side, means it is undergoing what? It is undergoing oxidation. I'll write this: nickel undergoes oxidation to nickel 2 plus by loss of 2 electron. Oxidation always we represent in this way, that we write electrons on the right side. Okay. Reduction half reaction, obviously reduction half reaction. What is happening in the reduction? Silver is getting reduced. Ag plus accepts 1 electron and changes to Ag. So if you see over here that here there is 1 electron and here there are 2 electrons, so I'll multiply this with 2 electron. I'll multiply by factor 2, so that number of electron becomes equal in both the half cell. So what I get is, I'll write short form oxidation half reaction to be is equal to, as it is, nickel 2 plus and a 2 electron, and reduction half reaction I am writing it to be 2 Ag plus 2 electrons and 2 Ag. To be more specific, I'll write the states in which all the reactants are existing. I'm writing nickel, 0 oxidation state means solid, plus 2 in the ionic form means aqueous, and this is 2 electron. Here also it is 2 times Ag plus means aqueous, it has some concentration, 2 electron and Ag solid. What will be the overall reaction? These 2 electrons which are there on the opposite side will get cancelled. Overall reaction is this: nickel plus 2 Ag plus, giving you nickel 2 plus. I'll write the states also, those states are very important. Nickel solid, 2 Ag plus, okay, this is the overall reaction. This is the overall reaction we should be getting. See how I write the Nernst equation, how I do the substitution. EMF of cell is equal to E naught cell. We'll focus on this E naught cell later. First we'll understand how to write the substitution, proper substitution. 0.059 and upon n is 2. I have cancelled 2 over here, means 2 electrons total transfer. Log of concentration of the product, these are the products and these are the reactants, right? So concentration of the product means I am writing this first, that is nickel 2 plus, I think that there should be 2 over here, and concentration of the Ag raised to 2, and the reactant nickel solid, here this is also solid, and concentration of Ag plus the whole square. Okay, this should be the proper substitution. If you have done this way, writing the formula like this stoichiometric coefficients over here are very important. This will decide your answer. Okay, now what is E naught cell? First we'll calculate the E naught cell. E naught cell is equal to E naught cathode minus E naught anode. Now from this, how to identify which one is cathode? See, many times in this example the whole cell representation is given. You see the cell representation is given over here. It is very easy, but sometimes the cell representation won't be given, but they have given the reduction potential over here. You see that there is a reduction potential given over here. So I'll write for the nickel E naught for nickel 2 plus getting converted to nickel is 0.25 Yes, minus 0.25. This is minus 2.25, and E naught of Ag plus getting converted to Ag is 0.80 volts. This is volts. Yeah. Now, how to identify? If only this is given, understand? I am explaining everything in detail. If only this is given, how to identify which is cathode and anode? How to understand that electrode having higher reduction potential will undergo reduction, and other opposite electrode will undergo oxidation. Means what? One which undergoes reduction is cathode, and one which undergoes oxidation is anode. Means in this case, this is having higher reduction potential, therefore this is cathode, and this is anode. I'll tell you the short trick how to remember. Just remember this, LOAN. Just remember this. Remember this word, LOAN. L stands for left. Anode always represented in left side. The oxidation takes place on this. It is anode, and the polarity is negative. Okay, if you remember this, you'll remember rest of the thing. So what is E naught cell over here? E naught cell is cathode 0.80 minus 0.25. So the answer comes to 1.05 volt, right? Therefore EMF of the cell will be is equal to 1.05 minus 0.059 upon 2 log of, okay, what I'll do is I'll copy this over here. This was that our substitution part. Copy, paste. Okay, I am substituting in this formula. You don't have to write again and again these formulas. So this is E cell 1.05 minus 0.059 upon 2 log of concentration of the nickel in a problem is given as 0.025. Silver is a solid, so I consider the concentration to be unity. Nickel again is unity, it is a solid, and Ag plus is given as 0.005. 2.005. So we'll write this. I have the freedom of copy and pasting it. Copy and paste over here, same thing. So what I write over here is this, log of 0.025. Here there is a square, here this square term is there, sorry. And what is this? 0.005 whole square. Okay, I'll just solve this logarithm part over here. Small rough work I'll do. This could be written as 25 into 10 raised to minus 3 And this could be also written as 5 into 10 raised to minus 3 the whole square. So this will be 25 into 10 raised to minus 3, and this is 5 square. This is 25 into 10 raised to minus 6. This and this will get cancelled. So what remains is log of 10 raised to 3. Therefore, EMF of cell will be 1.05 minus 0.059 upon 2 into log of 10 raised to 3. From the identities of the logarithm, can write 1.05 minus 0.059 upon 2 into 3 log 10. 3 log 10. So what is this? This will be 1.05 minus 0.059 upon 2. Log of 3 is what? 1. Like this is from the identity what I have converted to this. Like log of a raised to x is x log a. So 3 log 10. Log of 10 is 1. So finally 1.05 minus 0.059 into 3, 0.059 into 3 divided by 2, 0.0885. So answer is 0.9615 volt. Writing this answer you will get 2 marks for this. It looks very complicated. It looks like very long answer, but it took a lot of time because I had to explain. When you will do it, you will do it very easily. And now you must be thinking why these things are asked, why these values are given. Don't worry about these values. The temperature is 298. Directly you have converted everything to this. Okay. Calculate the standard Gibbs free energy change and the log of Kc. Gibbs free energy change is given as delta G is equal to minus NF E naught cell. Okay. E naught cell is directly given. We need to know what is N over here. Like that, you can use the trick 3 into 2 and 2 into 3 is 6. So 6 is the N value. But still I'll break up this reaction and I'll tell you what is happening over here. Oxidation half reaction. Okay, you see that chromium is going from Cr to Cr3 plus. I'll write Cr is going to Cr3 plus. Therefore, loss of 3 electron. And reduction half reaction is what? Cadmium 2 plus is changing to cadmium by accepting 2 electron. Fine, solid aqueous. So to make the number of electrons equal, I'll multiply this by 3 and I'll multiply this by 2. So your oxidation half reaction therefore oxidation half reaction becomes equals to 2 Cr 6 electron, and this becomes this, and this will get cancelled and you will get that overall reaction. So cancelling part, I have cancelled 6 electron, that's why it is N is equal to 6 over here. Okay, I'll write still again Cr 3 cadmium 2 plus. This is the equation which I am writing. It is already given. You should be getting that from the half cell equation. So what is E naught delta G? Delta G is minus N. N is 6. Faraday is 96500. And E naught cell is what? 0.34. So over here, answer will be 6 into 96500. 0.34. minus 196860. Units will be joules. How the units will be joules? Let's illustrate this. You don't have to illustrate, I'll explain you. Your understanding. This n value, the units will be moles. Just write the units. N moles. 96500 coulomb per mole. Coulomb per mole. And this is 0.34 is volt per mole, and mole will get cancelled. What remains is coulomb volt. Coulomb volt is equal to joule. Okay, so the answer is joules. Second is asked what is log of Kc. Log of Kc means what? The reaction is at equilibrium, means when there is a equilibrium taking place. So I'll start with the Nernst equation. E cell, you can easily remember the formula also, no issue. 0.059 upon n. This is log of concentration in anode half cell upon cathode half cell. So at equilibrium what happens is that you don't have to write this, I am just explaining you if in case you forget the formula, because many students remember this formula. Okay, so at equilibrium EMF of cell is equal to 0. Cell doesn't work at equilibrium. So this is equal to 0. This is equal to 0. E naught cell minus 0.059 upon n, and this becomes product upon reactant to be is equal to log of Kc. Kc is equilibrium constant. So therefore E naught cell is equal to 0.059 upon n log of Kc, and you are asked log of Kc. Therefore log of Kc will be is equal to what? N E naught cell upon 0.059. So n is what? 6. E naught cell is 0.34 and this is 0.059. So therefore log of Kc is 6 into 0.34, 6 into 0.34 divided by 0.059, 34.57. If the Kc was asked, you will have to take the antilog of this. Next question is a transition element which does not exhibit variable oxidation state. Answer is scandium. Scandium does not exhibit variable oxidation state. It has only one oxidation state. The last element of the lanthanum is lanthanide state is lutetium. That is Lu. The ore from which potassium dichromate is prepared is chromite ore. Okay. So chromite ore, the general formula of the hydroxide formed when lanthanide reacts with water. So lanthanides are in a +3 oxidation state. So this is the formula 3 times. Okay, so these are the answers for this. This question is asking you the expression. Okay, let's read the question. Derive an expression for Raoult's law when the solute is non-volatile. Okay, we'll write this, we'll derive this, and later I'll answer your question. What are azeotropes? Okay, so first we'll understand. Derive an expression for the Raoult's law when the solute is non-volatile. So basically Raoult's law tells you about the vapor pressure. Like, I'll write the Raoult's law. Actually, not required. Okay, I'll not write the statement. Let us understand the meaning of it. Okay, we'll write the statement and we'll understand the meaning of it. First, we'll understand what is Raoult's law. Not required. This is not ask. Okay, this is not ask. The statement is not asked, but unless and until we understand the Raoult's law, it won't be able, it won't be possible for us to understand this expression. So, what the Raoult's law says that it states that at any temperature, okay, I'll write short form. You don't have to write for exam in short forms. The partial vapor pressure of volatile components of a solution is equal to the vapor pressure of that component and its mole fraction in solution. Now this statement you don't have to write. Okay, this is for our understanding. So it states that at any temperature, partial vapor pressure of the volatile component of a solution is equal to the vapor pressure of that component and its mole fraction in the solution. Like, let us consider the system this way. We'll consider the system. You have the components this way. Okay, this is the liquid, okay, and let's say there are two components in this. One is this. Okay, this liquid is made up of two volatile components, and other is this. Okay, like mixture of the two liquid, both are volatile, and I'll close this system. Okay, there is a lid on this. So what will happen is that some of the particles from this will be in the vapor phase. All right, some of the particles will be in the vapor phase. Okay, some of the particles will be in the vapor phase, and they are going to exert a pressure on the surface of the liquid. Now this is what the surface of the liquid is. On this surface they are going to exert a pressure. More the number of the particle, they are going to exert a more pressure on the surface of the liquid. Means they are going to exert a more pressure on this surface. This is what the vapor pressure is. Okay, now this is there will be also, since other component is also volatile, there will be certain amount of the other component in a vapor phase, right? If you ask me over here, the vapor pressure of the red component is more compared to the green component. Why? The composition, the amount of the red component was more compared to that of the green component. Let's name it this way. So over here, the partial vapor pressure, or we'll understand it this way, the partial vapor pressure, there are two components. I'll mark one component like this as A and this as B. Means I'll consider one as a solute, I'll consider this as solvent, this as solvent, and I'll consider this as solute. Okay, or I'll say this is A and this is B. By convention, B is always solute, understand, and A is solvent, or 1 is solvent and 2 is solute. It is that way. So over here the vapor pressure is due to both the components, understand this. The vapor pressure is due to both the components, that is A and B. So P total that is vapor pressure will be is equal to partial vapor pressure of A plus partial vapor pressure of the B. Okay, so what is P total now? According to the Raoult's law, when I discuss, okay, I'll write over here, according to the Raoult's law, partial pressure of A is directly proportional to the mole fraction of the A. Means what it tells is that the partial pressure of the any of this component is directly proportional to the mole fraction. Means mole fraction indirectly tells you the amount of the substance. Means more is the amount of the substance, more will be the partial pressure, right? So this is what according to the Raoult's law. If I continue further, it will be, if I remove this proportionality sign, I will write P naught A XA. Now this is a constant, means this is a vapor pressure of that liquid in a pure form, means it is not mixed with any other substance. So this is what according to the partial, or the according to Raoult's law, and this is a partial vapor pressure. So I can write this as a P naught A XA, and other will be obviously P naught B XB. Now this expression which I have written over here, is for what? Is for when both the components are volatile. Means volatile means what? Both A and B will contribute to the pressures over here. Now we'll consider the system where the question is asked solute is non-volatile. Means I have a system like this. Now we'll come to the question. Okay, where when solute is non-volatile means it will not evaporate. Okay, we'll consider the system this way. We'll consider a beaker. I'm using the word system. Okay, and there are two components in this. I'll close the lid. Okay, one is solvent. Okay, one is solvent, other is solute. Okay, in this picture there will be only solvent molecules. In this phase, the solute, this green particles or green molecules won't be over here. Because these green are non-volatile, they don't evaporate. Means over here the partial pressure or the P total will be is equal to what? According to Raoult's law, I should be writing P total should be partial pressure of A plus partial pressure of B, right? Since B is non-volatile, B means solute is non-volatile, it will not contribute to any pressure. So P total will be is equal to just PA, right? P total will be is equal to PA. So what is this? This is equal to P naught A XA, because this component is 0. This partial pressure of the solute is 0, B, right? So I'll write this P total will be is equal to PA. Means therefore I write that P total will be only due to partial pressure of A, which is equal to P naught A XA. right? And if I write it over here this way, Pa upon P naught A is equal to XA. Fine. I can write this term XA as, you can write this term XA as 1 minus XB. How is this? Sum of mole fraction, sum of mole fraction, sum of mole fraction of any number of components is always equal to 1, always equal to 1. Means over here there are two components, no? That is mole fraction of A plus mole fraction of B will be is equal to 1. Therefore, XA is equal to 1 minus XB. This is what I have written over here, 1 minus XB. So therefore, I can write this as, if I rearrange this term, I can write this as 1 minus Pa upon P naught A is equal to mole fraction of the B. Therefore, P naught A minus Pa is equal to XB. Means this is the expression. What is asked? This expression is also telling you about the relative lowering of vapor pressure, Now what you have to write for the exam? You have to write for the exam only this part. Which part? Which I have written in black. This was the thing which I was explaining. These things what I was explaining over here, these were the things which I was explaining over here was for you to understand the concept when both the components are solute, both are volatile. So what you have to write for the exam is only something which I have written over here in the black. Okay, this was expected from you to write for the exam. Next question is identify the structures of the compound A, B, C, D. Okay, these are the reactions. Okay, and over here the first reaction is this. First reaction is C2H5CONH, means it is this. CH3 CH2 C double bond O NH2. In this reaction, if you see, there is bromine reagent and aqueous KOH. If you know these reagents are the reagents of a Hofmann bromamide degradation. Hofmann bromamide degradation. This word is very important. Degradation. The speciality of this reaction is this part is removed. Means what product you get. How to remember this reaction is directly this CH3 CH2 NH2. You remove this. Means basically product what you get, like this reaction. I'll write a short note of this reaction, Hofmann bromamide degradation reaction. You have to understand the speciality of this reaction is that, or a important thing about this reaction is that you get one carbon less. The product what you get over here is, note, product in Hofmann bromamide degradation reaction is one carbon less, one carbon less. This is this amide, this is actually the amide, like it is propane amide, propane amide, and what you get is ethane amine. This question could be framed like, if you want to prepare ethane amine, which amide which you will be using. So this is the thing about this reaction, and this is your product A. This is your product A. This is your product A. The second step, they are asking about the B. So for the B, I'll write here fresh CH3, CH2, NH2. You have to understand the reagents over here. The reagents ask is written is CH, Cl3 plus alcoholic KOH, alcoholic KOH. So what else is there? Plus heat is there, plus some amount of heat is there. 1 minute. Over here, okay, so, chloroform, we are using the chloroform, and yes, heat. So this reaction is this reaction is also known as isocyanide test. Cyanide test means what product you are getting at the end is a isocyanide. CH3, CH2, NC. Like over here, this is ethane amine, this is ethane amine, and what you get is ethyl isocyanide. Understand? Cyanide. Isocyanide is because N is connected. If C was connected, CN, then it is cyanide. Okay. One more thing about the Hofmann-Bromamide degradation reaction you have to note is that here it is a conversion of the amide to what? Amine, or I'll write it specifically. It is a conversion of amide to amine. Okay, what is amide? Amide is represented this way. This is your amide. This is your amide. What is amine? RNH2. This is amine. These are the small things you should be knowing. Very important. So done. Next is Fe and HCl. Okay. Second reaction. This was our first reaction. Second reaction is this. There is a NO2 given. There is NO2 given, and Fe and HCl. Okay, I forgot to mention that this is our product B. The earlier was A. This is a reducing agent. Understand? Fe and HCl is a reducing agent. This is what? This is reducing agent. Reducing agent. What it will do? It will convert NO2 to NH2. Now, why this is called as reduction? You see, the definitions of the reduction is that it is a removal of the oxygen and the addition of the hydrogen. So here both either it is a removal of the oxygen or the addition of the hydrogen. In this process, you see both the things are happening. There is a removal of the oxygen and there is a addition. Means NO2 is converted to NH2. Means this was a nitrobenzene. This was nitrobenzene. It is converted to aniline. And further, if you see, it is reacted with HNO2, right? NaNO2 plus HCl. This reagent could be also given this way, HNO2, nitrous acid, because this combo leads to the same thing, HNO2 only, nitrous acid, very unstable acid. This converts this to a benzene diazonium salt. What you get is this N2 plus Cl minus. This is called as benzene diazonium salt. See, we are getting a salt because this is base. Okay, one more trick we have to understand. This is a base and this is what? This is acid, or this combo is again a acid. Acid base gives you a salt. So this was our, I guess it is C, and this is our product D. So this is the reactions which is expected. You to write, I guess 1 marks it was, total 2 marks I guess. Yeah, total 2 means half for this, half for this, half and half over here. Okay. Draw a neat label graph to show the action of the catalyst on the activation energy. So we have to draw the graph which shows the action of the catalyst on activation energy. Okay, I'll draw the graph. I could have pasted it directly, but I like explaining nicely this way. Like what you have to write on the x-axis is, this is potential energy, over here this is reaction coordinate. Okay, simple graph it is. First I'll draw the graph with I have the freedom to use different colors over here. I'm using it. Let's say this is my reactant energy and this is the product energy. This is the energy of the product, little less. Okay, this graph which I have done is without catalyst. This is without catalyst. So catalyst usually I'll show you what is activation energy. Like over here, from this point to this point, this is activation energy. This is activation energy. This is without catalyst. But if I add a catalyst to this, what will happen is that the graph will look like this. For exam, you don't have to use different color. One you can make complete line, and other you can make a dotted line. Okay, so this is the graph, and what will be this? Over here again I'll write this is the new activation energy. Like this is 1, I'll write this is EA2. EA2 is less. So this graph which you are getting is with catalyst. So with catalyst lowers the activation energy. So you don't have to write all these things. What you have to write for the exam is only this much. Only this much you have to write. Okay, reaction coordinate. Again, don't use short forms. Don't use short forms like this. You will lose marks. Simply reaction coordinate. Next question. Again, it is an organic one. Question number 19. It is again for the 2 marks. So first reaction over here, if you identify this reaction, can someone comment what reaction it is? Pause the video for some time and try identifying the reaction. The first reaction, name of the first reaction. Name of the first reaction is Williamson synthesis. Okay, it is for the preparation of the ethers. The speciality of this reaction, or something to note about this first reaction, that this should be always tertiary and this should be primary. Okay, if it is opposite, if this is primary, and if this is tertiary, then the reaction goes in the direction of the elimination. You don't get the ether as a product over here. So the reaction over here will go this way. Or I'll write the product here only. Why to simply consume the time? The product will be CH3, O, CH2, CH3 plus NABR. Okay, you have to also write the name of this. Write the name of this name is NABR is there. The name of this compound is, like if you do the UPSC nomenclature, this is 1, this is 2, this is 3. This is the parent chain. These are the 2 substituents on this. So ethoxy, E comes first. So 2-ethoxy, 2-methyl, one word, it is propane. Okay, I'll write down. It is one word, pro. I'll write over here. Propane. Plus you will get NABR. Plus NABR you will get as the product. Plus NABR, sodium bromide. Okay. What about this reaction? This reaction is very straight and it is one of the name reaction. That's why many time I tell student, you should be focusing like whether you learn any reaction or not, but always focus more on a name reaction, like named after the scientist. Okay, those reactions are always which has more probability to be asked in exam. Like the name of this first reaction, if you ask me, this is Williamson synthesis. Williamson's synthesis. This is very important. Second reaction, can somebody guess what would be the product for the second reaction? You can comment your answer over here. You can comment your answer. NaOH and CO2. The name for this reaction is a Kolb's reaction. Kolb's reaction. The reaction is very straight. The product what you get over here is a salicylic acid. The OH. The common name for this is salicylic acid. Salicylic acid, or IUPAC name 2-hydroxy benzoic acid. Okay, this is phenol. Okay, fine. With reference to the coordination complex, okay, there is a complex. Write the IUPAC name of this. IUPAC name is very simple for this. This is Fe written H2O6 and a 2 plus. This is a coordination sphere, and in the coordination sphere we always name ligands first. It is hexa aqua. This is positive coordination sphere, so therefore iron and not ferrate. If it was a negative coordination sphere, you would have written ferrate. Oxidation state of the iron is same as the charge on the coordination sphere, 2, right? That is plus 2 over here. Like if you do this, find oxidation state on iron in this complex is X plus 6, water is neutral, equals to, what is this charge? Plus 2. X will be is equal to plus 2. Now this is, there is no counter ion for this, so it is very compulsorily you should be writing further. It is a ion, okay? Hexa aqua ion 2 complex. State the hybridization of this. Whenever it is a hexadentate ligand, this complex is a hexadentate, sorry, not hexadentate, sorry. This has the ligand, there are 6 ligands. How do I understand? That there are 6 water molecules connected. 6 water molecules. So hybridization, like geometry surely will be, geometry did not ask, but geometry surely it is octahedral only. But hybridization, there are 2 possibilities of the hybridization. One is sp3 d2 and other is d2 sp3. This is known as outer orbital complex, and this is known as inner orbital complex, Now when do we have the inner orbital complex and an outer orbital complex? For that you should know the strength, ligand strength. What kind of ligand is this? Means is it a weak field ligand or the strong field ligand? Understand that when do we get a outer orbital complex? sp3d2 is for a weak field ligand. Whenever there is a weak field ligand, you will get the complex outer orbital complex, that is sp3d2 will be the hybridization. And whenever it is a strong field ligand, you will get inner orbital complex. Okay, since water is a ligand and water is a weak field ligand, since water, that is H2O, is weak field ligand, therefore hybridization is sp3d2. Okay, you can write, even if you write this much for this question, you are expected to write only this much. Even if you don't write the reason, then also it is fine. Only hybridization was asked. So sp3d2 if you write, you will get the marks. Write chemical equation to carry out the following conversion. Not more than one step. Okay, this is also mentioned over here. Okay, so we'll do with this, that is 2-iodopropane to 2-bromopropane to 2-iodopropane, CH3, Br is here, second position. I need to convert this to this 2-iodopropane. I'll name this. Propane. Actually, over here, this reaction, okay, if you go through the NCRT, my dear students, then you understand that this is also a haloalkane and this is also a haloalkane, but this reaction is specific for the preparation of the iodoalkane. Okay, this reaction name is known as a Finkelstein reaction. If you go through your NCRT, the reaction name is given as a Finkelstein reaction. Write the name Finkelstein reaction. Falls under the category of the halogen exchange reaction. Like halogen is getting exchanged. There are two reactions. One is Finkelstein reaction and other is a Schwarz reaction. Schwarz reaction is for the preparation of the fluoroalkane. Okay. So over here the reagent used is a sodium iodide and the other product what you get is a sodium bromide. So this is that reaction which you are expected to write for the 1 marks. Okay, total marks over here is 2, I guess. Yeah, it was for the 2 mark, 1 mark for this and 1 mark for this. Okay, second reaction is a conversion of the chlorobenzene to 1-chloro-4-methylbenzene. This is happening 1 minute. Okay. So conversion of 1-chlorobenzene. This is chlorobenzene. You need to convert this to 1-chloro, 1, 2. This is first position, this is second, this is third and this is fourth. Here you need to get the methyl. Okay. How you will do this conversion? I will write a reaction first. I will write this is CH3Cl and anhydrous AlCl3. Okay. This is very sweet reaction. Okay, I'll just explain this concept also, because many times what happens is that students don't know the concept. If you understand this one reaction, there are many other reactions similar to this, you can understand them also. Okay, this reaction, I'll write the name of this reaction. Name of this reaction is Friedel-Crafts alkylation reaction. Okay, this falls under the category of the electrophilic aromatic substitution. Okay, means what is the meaning of this electrophilic aromatic substitution? A electrophile is substituted on the benzene. Means aromatic means I am talking about the benzene. That is a simple thing. So mechanism, I will write over here the step 1 of the mechanism. Mechanism, very basic thing. Step 1 is generation of an electrophile. Is generation of an electrophile. All this is not required for you to write in an exam. What is required for you to write in an exam is only this part to get that 1 mark. I am just explaining this. So generation of an electrophile. So over here, what is the thing? This is CH3Cl CH3Cl is reacting with AlCl3. AlCl3. What is AlCl3? AlCl3 is a Lewis acid which accepts the electron pair from this, which accepts the electron pair from here. And what product you get is CH3 plus and AlCl4 minus, and this is the electrophile which is generated. Okay, next step is, I'll write step 2. Step 2 is substitution of electrophile. Substitution of electrophile electrophile on benzene. Okay, in this case it is chlorobenzene. Now it will have the directive influence, means this substituted benzene, the chlorine will direct the incoming electrophiles. Understand, there are something called as ortho para directing and the meta directing group. If you just search on Google, you will get which are the groups which will direct an incoming electrophile to a ortho para or a meta position. So over here this group is a ortho para directing group. Ortho para directing group, directing to incoming electrophile. Incoming electrophile. See students, even if you know this much, this can solve one of the questions of the JEE or NEET. So what is the electrophile? CH3 plus is the electrophile, and the major product is always para, because ortho you will get two products over here, one Cl and CH3. This is para product which is major because it is more stable, and ortho is less stable because of the close encounter of these two groups. Okay, so this is minor. You have to write the major one for this. So this was the whole mechanism for this compound. Next is an organic compound having molecular formula C3H8O. Do not produce turbidity with Lucas reagent. Understand that Lucas reagent. What is Lucas reagent? It is ZnCl2 plus HCl. Again, you don't have to write all these things. I am just telling you for your information. Lucas reagent is used for the detection, used for detection of primary or secondary or tertiary alcohol. This Lucas reagent can tell you about this. Basically, tertiary alcohol reacts with Lucas reagent to give turbidity immediately. Turbidity means silver chloride is formed, not silver chloride, some precipitate is formed over here, turbidity, very fast, quickly. Okay, if it is a secondary alcohol and if it is reacting with a Lucas reagent, you get a turbidity, you get some precipitate, maybe more than 5 minutes, and primary alcohol reacts with Lucas reagent to give turbidity. It takes very long time, turbidity, long time, maybe more than half an hour, long time, more than 30 minutes. Here the condition what is said is organic compound having molecular formula C3H8O do not produce turbidity Lucas reagent at room temperature. It is not possible. Actually, Lucas reagent and the primary alcohol do not react with the Lucas. They don't react to give any reaction at a room temperature, it requires certain higher temperature. So it is very sure that if this is the formula, what is that? C3H8O. Okay, C3H8O. Understand, if this is the thing, there are two possibilities. One is possibility is ether or alcohol. Understand, it can be ether or the alcohol, but it is alcohol. Let us assume that it is alcohol first. Okay, so alcohol, then what type of alcohol? A primary, secondary or the tertiary alcohol? Since it is said that Lucas reagent is not reacting, so this is a primary alcohol. This is primary alcohol. So primary alcohol having a 3 carbons will be this CH3, CH2, OH, that is propane 1-ol. Okay, this is what you have to write now. Second is what? The compound E. Yeah, we are talking about this. This is our E compound. The compound E upon oxidation with CrO3. If you oxidize the primary alcohol, it is not very strong oxidizing agent. What you get is the aldehyde. Means what aldehyde you will get? You can refer to my short trick. I have made one specific video where I have explained how to remember reactions. Like video name is one trick or something like that. One trick, 10 reactions you can remember. You can watch that video, you'll understand this part. So this is C double bond OH. This is aldehyde. This is propanol. Like how do I get this? Like how do I say that this is the alcohol in ether? Because in the question they have mentioned that E is the compound, E compound on oxidation with CrO3 in anhydrous sodium forms F, which shows Tollens test positive. Now Tollens test is positive if you react a Tollens reagent over here, Tollens reagent, then it is positive for the aldehyde. Means this should be aldehyde. If this is the aldehyde, then this should be alcohol. So this is our compound F. You will get the positive Tollens test, right? Write the structure and the IUPAC name of the compound. So I have written E is the propan 1-ol and F is propanol. That's it. Write the products formed at electrodes during electrolysis of aqueous sodium chloride. Understand that over here anode means always oxidation. Anode means what will happen is oxidation. And what is cathode? Cathode will do reduction. Okay. Now there are different types of ions. Like there is H plus. Okay. There is Cl minus ions in that case. So what will happen at the anode is that Cl minus will get converted to Cl2. Means here what is this? This is oxidation is happening. Means the gas released at the anode will be chlorine gas. So product of electrolysis, anode Cl2 gas will be produced. You can write like how to write this. Like what you have to write, at anode Cl2 gas will be produced, because this is oxidation. So from -1 to 0 is the oxidation. What will happen at the cathode? There is a H plus. This changes to hydrogen gas. So from +1 to 0, this is reduction. Means at cathode H2 gas is produced. It is that simple. Calculate the molar conductance of 0.25 molar solution of NaCl at 25 degrees Celsius. The specific conductance of 0.02, it should be 0.025 molar NaCl. is given as 0.02 Siemens per centimeter. Molar conductance. What is the formula for the molar conductance? Molar conductance formula you have to remember. Lambda m, conductivity 1000, conversion factor, and upon concentration means molarity. So conductivity is given directly over here as 0.02 into 1000, and the concentration is also given, that is 0.25 molar. When you solve this, lambda m, see, there is a half marks for writing a formula. Understand, there is a half marks for writing a formula. Half marks for correct substitution. In between there is no marks, but there is marks for steps. If I write this will be 20 upon 0.25, which is equal to lambda m, which is equal to 80 Siemens centimeter square per mole. Understand? You have half marks for this. You get half marks for writing a correct answer and half marks for the unit. Total 2 marks. Okay, this is how the distribution is. Never forget that. Never forget to write the unit. You will simply lose half marks. Okay. Find the coordination number and the oxidation state of the central metal atom ion in the complex. Okay, we have to understand that coordination number and the oxidation state. We'll find for this. The complex given is the cobalt Cl2 OX2 3 minus. First we'll talk about the coordination number. Coordination number. Over here there are two ligands, chlorine and the oxalate. So chlorine is a unidentate ligand. Cl is what? Unidentate ligand. Unidentate ligand. So one chlorine has just one linking site. One chlorine has just one linking site. What about ox? Ox stands for oxalate. This is didentate ligand. Didentate or bidentate also we say. Didentate ligand. And in one ligand there are two linking site. So total atoms or total coordination of this due to ox will be oxalate coordination number due to oxalate will be, there are already 2 into 2 is 4, and Cl there are just 2 into 1 because there is only one linking site, which is equal to 2. So sum is what? 4 plus 2 is equal to 6. So therefore coordination number is equal to 6, and you have to write only this much for the exam. You don't have to write all these things you don't have to write. Okay, this is I have written for your understanding. What you have to write? Only this much is asked. Okay, how much you'll write for 1 mark? Whole paper is also there. You have to finish that paper. You cannot sit explaining everything. Second is oxidation state is asked. Okay, I'll write the compound again. It is cobalt Cl2 oxalate twice and it is 3 minus. How to find the oxidation state? On a cobalt, I'll put cobalt as X plus cobalt as X plus 2 into -1. Chlorine is -1 plus 2 into oxalate. Oxalate is minus 2. What is oxalate? COO minus. COO minus means C2O4 2 minus. C2O4 2 minus is the oxalate, which is equal to, what is this overall charge? Minus 3. So x minus 2 minus 4 is equal to minus 3. X minus 6 is equal to minus 3. X is equal to minus 3 plus 6. X is equal to plus 3. Plus 3 is the oxidation state of the cobalt. Okay, if you feel that this video is adding value to your preparation, you can like, share and subscribe. Okay, please like, share and subscribe. Share with your friends also. One minute, I am getting one call. I'll just message that person. Okay, so write one point of difference between a primary valence and a secondary valence. Okay, so I'll write over here primary valence. This is what you have to write, like this: systematic primary valence, and the other is what? Secondary valence. Only one difference is asked. Okay, so what is primary valence? It is oxidation state of metal. Like in this case I am getting a plus 3 as oxidation state, means this is a primary valence. What is secondary valence? Secondary valence is coordination number. It is a coordination number satisfied by ligands. This is my, you can, in simple terms you can say that this is primary valence, and this is secondary valence. Okay, so these things are that simple. Again, I'll not go into these things over here. Differentiate between fibrous protein, globular protein. You can just go through this NCERT nicely written, or you can just Google this. Next question asked over here is arrange the given set of compounds in the decreasing order of the acidic strength. I'll write the compounds again over here. The compounds, one of the compound over here is the alcohol. Others all are carboxylic acid. Okay, remember students that always acidic strength, if you ask me, acidic strength, if you compare between alcohol and the carboxylic acid, then carboxylic acids has more acidic strength than alcohols. Okay, so if you compare carboxylic acid and the alcohols, so what we'll do is, since they have asked a decreasing order, we'll consider only the carboxylic acids first. We'll consider these carboxylic acids first. We'll discuss about them, and last, anyway, what will come is least acidic will be over here ethanol. So what is the meaning of acidic strength? Okay, what is the meaning of acid, right? We'll figure it out. So here I'll write the acid. The one which is given is this. One acid given is this. CH3 COOH. Another acid is Cl, then CH2 COOH. Next given is fluorine connected to this fluoroethanoic acid, or 2-fluoroethanoic acid, we can say. This is 2-chloroethanoic acid. And one more is there, which is benzene, C6H5. I'll write this way, CH2COOH. What is the meaning of acid? A substance which can give away its hydrogen very easily. So whenever this acts as an acid, it will split this way, CH3CO, right, in a more open form, O minus and the H plus. Over here, this will also split this way. This is Cl, this is CH2 COO minus and H plus. This compound will again split this way, CH2 CO O minus and H plus, and this compound will split this way, benzene, this phenyl connected to this O minus. In every case we are getting a H plus. I did not write alcohol because reason is very simple. Alcohol will be always least acidic than a carboxylic acid. We have to compare over here. So over here, the better acid, one which is better acid is that which is stabilized. Over here the negative charge which is formed, okay, in which case that negative charge is more stable, that will be a good acid. Always remember that negative charge, this is for you to note, that negative charge is stabilized by electron withdrawing group. Okay, so over here if you see, there is a fluorine because it is more electronegative, and then chlorine. These are the groups which are more electronegative, okay, or they are electron withdrawing groups. You can consider this group as an electron withdrawing group. So since they are withdrawing group, they are going to stabilize this negative charge to a more extent. So among all these acids, either fluorine or the chlorine are the most acidic. Now between fluorine and the chlorine, which is most acidic? Like fluorine substituted, not fluorine exactly, like on which substituent is a fluorine, that will withdraw the electron density from here to more extent. This group will neutralize or this negative charge to more extent. That's why this is a good acid or a strong acid. Which acid? F CH2 COOH. After that comes chlorine, Cl CH2 COOH. Then there comes two compound. There is a methyl and phenyl. This is the phenyl group. Both are electron donating. Both methyl and the phenyl are electron donating group. I'll write over here, this is electron donating group. This is also electron donating group. What is this? Chlorine, electron withdrawing group. So basically this electron donating group, phenyl and what, both this methyl, they will tend to destabilize. Now the question is, which is going to destabilize it to the more extent? Understand that phenyl is a less electron donating group than a methyl group. So this electron donating group, this phenyl group, will destabilize, or this phenyl will destabilize this to less extent. Therefore what will come over here is over here, after this is this concept will help you even for If you're answering any competitive exams, JEE on it, these things will help you out with this. These are the concepts of the GOC. Then comes your CH3 COOH, and least will be finally that ethanol, right? CH3 CH2 OH. So this is the whole explanation for the first part of this. Okay, next is ask this reaction. Next question. Okay, give a chemical test to distinguish between propane to all and butane to one. Okay, there is one more question. Basically, this question is for 3 marks. So give a chemical test to distinguish between propane to all and butane to one. So we'll write. Next question ask is in the same question, sub question ask is how to distinguish between a propane to all and a butane to one. Understand over here the test which will work is I feel that Lucas reagent will work for this. The reason is Lucas reagent will give, like Lucas reagent reacts with what? Reacts with alcohol, no? Alcohol, and this is secondary alcohol. This is secondary alcohol. So you will get the turbidity over here. Turbidity after 5 minutes. Right, that is the thing. But what about butane 2-one? Butane 2-one, like Lucas reagent doesn't react with ketone, so no reaction over here, no reaction. So what best will work to distinguish between propane to all and butane to one is the answer for this is Lucas reagent. Lucas reagent. Okay, one of the students was asking me, isn't it a iodoform test? See, iodoform test would have worked, but over here you see that for the iodoform test to work on a carbonyl carbon there should be at least presence of one methyl carbon. Okay, yeah, over here this would have been positive iodoform test. I'm just talking about iodoform test. For this also there is one methyl group on which OH is connected. For this also iodoform test is positive. So you cannot distinguish for both the compounds. If it is getting positive, then you cannot distinguish, no? So iodoform test is not going to work for this. But alone, if you want to detect whether it is butane 2-one, then alone it will work. Okay, in that question, a reaction is given as this. One more question is there, sub question. They have mentioned Z and zinc, mercury and concentrated HCl. Okay, and the product given is CH3. Questions are too big. Yeah, this is what the product they have given, plus water. Understand this reagent which is mentioned over here, this reagent which is mentioned over here, this is a Clemenson's reduction, basically Clemenson's reduction. How that reaction is shown on the book in NCERT textbook, the reaction is shown this way. Okay, I'll write the Clemenson's reduction. This is your carbonyl. This is your carbonyl. It may be aldehyde or ketone depending upon these groups connected. Okay, and if you react zinc mercury in the presence of concentrated HCl, what you get is CH2 over here plus water. The name of this reaction is Clemenson's reduction. Name of this reaction is Clemenson's reduction. One more is there, Vogt-Fishner. It also product is same over here. Clemenson's reduction. So what would be a product over here? Product over here. If you are getting toluene, over here. Means this should be carbonyl. C double bond O H. I mean, this Z should be this. Z should be this. After you put these reagents, zinc and mercury and the concentrated HCl, what happens? You just write it this way. You put remove this oxygen and put the two hydrogens over there. So that will change to what? CH3. This is CH3. So this is benzaldehyde. The compound Z is what? Benzaldehyde. And what you get is a toluene. This is toluene. Same, it could be written as CH3 instead of this. It is CH3. So this question is complete. Next, draw the geometrical isomer of the compound. This is the compound which is given over here. Compound given is cobalt. Tetraamino dichlorido ion. Like geometrical isomerism you have to draw. Understand? Cobalt is there. There are 6 ligands connected to it. I'll show it this way. Like these are the ligands in one plane. Octahedral it will form. This ligand is above the plane and this ligand is below the plane. Means I can write 2NH3. This NH3 is over here. All the 4 NH3 in one plane. And both the Cl above and below. Okay. Both the Cls, one above, one below. I'll put positive charge. Okay. Like actually it is this NH3. I'll just show you. It is this way. How they are present? It is present this way. Means over here there is NH3. I'm just representing the positions where they are present. NH3. They are in one plane. And then this is Cl above and one Cl below. This is what the octahedral structure is. A small representation how these things are present. Okay. So over here both the Cls are on the opposite side of the plane. So this is the trans isomer. This is the trans isomer. What would be the cis isomer? Geometrical isomerism means it includes two, cis and trans. Okay, in this case it will be two, cis and trans, because it is of the type, this is of the type metal A4X2. So cis and trans isomer will be there. Okay, if it was A3X3, then there is a facial and meridional. So other isomer which will be present over here, I'll write again CO. I'll draw the coordinate bonds which are in the plane. So I'm drawing this first, which are in the plane. Okay. This is above the plane, this is below the plane. And over here, this is, I'll write Cl and the Cl on the same side. Like this is the plane and this is perpendicular to that. The rest NH3 you put over here. NH3, NH3 and NH3. You put plus charge over here. Okay, very important, since this is coordinate covalent bond, you have to show this arrow. Means electrons which are being shared over here belongs to one of the atom of the ligand. So this is what is expected from you to draw. Write the linkage isomer of the complex CONH. So this is the complex which is given, and you see that linkage isomer exists when there is a presence of the ambidentate ligand. What is the meaning of ambidentate ligand? The compound is given this way: CO NH3 5SCN 2+. Okay, ambidentate ligand means the ligand which has more than one linking site, but only one site will link at a time. Means this compound can link through sulfur or it can link through nitrogen. So linkage isomer of this compound will be CO NH35NCS, isothiocyanide. That's the thing. Next is mention any two limitations of the valence bond theory. I'll not write this, simply it increases the length of the video. You can just Google it, or NCERT, it is nicely given. We'll solve this question. Write the IUPAC name of this compound. IUPAC name of this compound. Okay, how to do the IUPAC nomenclature? See, there are substituents. There are substituent. Methyl is a substituent over here. Methyl is a substituent. Even bromine is a substituent. And there is also a double bond. There is no functional group over here. So whenever there is a double bond, and whenever there is a double bond and substituent, we give the priority to the double bond to get the lowest number. So numbering should be done in such a way that the double bond get the lowest number. So that numbering is here. Numbering starts from here. That is, this is 1, 2, 3, 4 and 5. If I start from here, double bond will get a higher number. So this is the correct numbering. How to do the naming of this? There is a methyl as a substituent and bromo. B comes first in alphabetical order. So I'll write over here only 4 methyl, 3 bromo. Done. 3 bromo. Substituent is done. Prefix is done. Then comes word root. Word root is, there are 5 carbons on a parent chain. That is pent. Then there is a primary suffix. At a third place, there is a, sorry, not third. At second, there is a double bond, E-N-E. I'm writing E-N-E. Last E I am keeping because there is no functional group. If functional group was there, I would have replaced last E with a suffix of the functional group. So this is the name of that compound. Name the reagent used to convert chloroethane to N-butane. Okay, questions are, in one thing only the questions are fitted. Chloroethane, I'll write this, CH3, CH2, Cl. You want to convert this to N-butane. N-butane means a straight chain butane. See, there is a reaction. There is a reaction in NCERT known as a Woods reaction. There is a reaction in the NCERT given as a Woods reaction. What does a Woods reaction say? Woods reaction say, it is basically the reaction of the alkyl halide. Reaction of the alkyl halide. It is represented this way. Rx. Either you put 2 Rx and don't put this one. Okay. Or you put 2 times Rx in the presence of dry ether. Dry ether. What you get over here is R connected to R and sodium halide. Put this way, 2 moles of sodium halide. Okay, this is the thing. Means to get this from chloroethane, what you will have to do is, you will have to write, if you write this reaction in this format, like this is our R part, this is our R part. Okay, and this is our halide, this is our X, and this is R part. If I write the reaction this way, CH3, CH2, Cl plus Na 2 moles, and again I am writing CH3, CH2, Cl, and I'll write in the presence of dry ether. I need to connect this R group with this R group, and this is how you are going to get the N-butane, CH3, CH2, CH2 CH3 plus 2 moles of NaCl. This is our N-butane. Means in short, the reaction asked is a Woods reaction. What is asked? A Woods reaction. Out of the given compound, to compound which is allylic halide. Okay. Allylic halide means what? One minute. Okay, which of this is allylic halide? Allylic halide means halide connected to sp3 carbon next to the carbon-carbon double bond. This is a carbon-carbon double bond over here. So this is a carbon-carbon double bond next to this. This is allylic. They have asked which is allylic halide. And what is this? Where halide is directly connected to sp2 carbon or a double bonded carbon. It is vinylic halide. So I'll just, our question is, answer is this. This is your allylic halide. Allylic halide. And what is this? This is not asked, but I'll write this is vinylic halide. Write a chemical equation to convert methyl chloride to methyl nitrile. Okay. More questions are there. Name the reagent used to detection of the double bond in a molecule. Which of the given compound will react faster in SN1 reaction with a hydroxide ion? So how to convert a methyl chloride to methyl nitrile? CH3 Cl. I need to convert this to methyl nitrile. Okay, methyl nitrile. Nitrile means cyanide group. So basically it is a substitution reaction, nucleophilic substitution reaction. Okay, I'll write some commentary about this reaction. Is that this is nucleophilic substitution reaction. What is a nucleophile? Cn minus is the nucleophile, means carbon carbon, and here is the negative charge. This carbon is getting substituted over here, is getting connected over here. So you have to use the compound, like you can either use KCl, you can use one of this. Means only one of this you should be using. Like many times students get confused over here. I'll write the thing over here, like KCl. If you are using KCN and AgCN, understand that this is your ionic compound, this is your ionic, and this is covalent. Okay, if you are using a KCN, this will split as K plus and a CN minus. Means I want this to be connected over here. So for this process, you should be using a salt of this KCN. Only this can give you a nitrile. If you are using a AgCN, what is AgCN? AgCN is a covalent compound. So over here there is a lone pair. This will get connected. This will get connected. Means I'll just tell you the extra about this. This is not the reaction which is expected from you. If it is this CH3Cl and if you are using AgCN, then what you get is CH3NC. See, when we compare and learn, that time the learning becomes easy. Okay, you will get isocyanide over here, but what is asked is methyl nitrile. So this is what is asked. So your answer should be this. Your answer should be this, not this. reagent used for the detection of what? A double bond. Okay, we'll do this detection. So there are many reagents you can use, like double bond means unsaturated. So most common reagent you can use is a Bayer's reagent. What you can use is a Bayer's reagent. Bayer's reagent. What is the meaning of Bayer's reagent? Bayer's reagent is a cold. It is cold dilute alkaline alkaline solution of KMNO4. Okay, so basically this KMNO4 is a purple color. Purple color. This is purple color. So whenever this is reacted with a double bonded like alkenes or the alkynes I mean alkenes or alkynes, this purple color disappears. Okay, and this KMNO4 changes itself to MnO2, MnO2, manganese dioxide. So reagent you can write this way. What was asked? So Bayer's reagent is this. So you can write this as an answer. Okay. So this is the answer which is expected from you. Which of the given compound will react faster in SN1 reaction? Okay, means there are two things it is given. One is CH3, CH2Cl, and other is this CH2Cl. See, SN1 reaction is a two-step reaction in which there is a formation. First step is a formation of the carbocation. So, SN1 reaction will be better where or better or we'll write SN1 reaction is better where there is formation of more stable carbocation, more stable carbocation, more stable carbocation. So ethyl chloride, when chlorine will leave, you will get the carbocation, primary carbocation. Here also, no doubt, here also you are going to get a primary carbocation. You break this bond and what you get a carbocation. Among this, which is more stable? Understand that this carbocation or in this compound, this carbocation is more stable. This carbocation is more stable. More stable. Though both are primary, here the stability is due to resonance pi sigma positive. Here stability is due to resonance. Anything which is stabilized, any intermediate which is stabilized by resonance is always more stable. Like tertiary carbocation is still more stable than this. That is an exception. But if you compare primary and the sometimes secondary, okay, if you compare secondary and the primary, but primary is stabilized by, if primary is stabilized by resonance, and that will be more stable. In this case, no doubt, both are primary, but in this case, this primary is what? Stabilized by resonance. So SN1 reaction will be more favorable for this compound. So this is C6H5.